This is the third and final video for 7.2 material. We are going to now discuss how to take the second derivatives. Second derivatives, no surprise, it's going to be dealt with the same way as what we've done before with the first derivatives, but this time you have to pay attention to which variable is going to be treated as the variable for each derivative step, right? So the first time you take a derivative, decide if variable is x or if your variable is y. And then for the second derivative, you can leave it the same or you can change the variable. So you're going to see it done in both ways. There's four types of partial second derivatives that we can take. The first one that's listed here is where we're taking the partial with respect to x both times. All right, so the first time we take a derivative, x is the variable. The second time, x is still the variable. The next partial derivative is here. This is where we take the partial with respect to x the first time through, but then the next derivative that we take, this time y is the variable. Okay, y is the variable. And then the next partial derivative that you can see, second partial with respect to y the first time, and then with respect to x. Now the cool thing is that these two are both going to be the same. Those are the same. Okay, so it doesn't matter which one comes first. If you do one and then the other, you're going to get the same answer. The fourth kind of second partial derivative is where you use the variable y, and then you use y again as your variable, so x is treated as the constant throughout the whole process. The mixed partials, that's what I identified up there in orange. The mixed partials are the same for any function, whether x comes first or if y comes first. It does not matter. So here we go, number 9. We're going to find all four partials, right? So we're going to start out by taking the partial derivative of f with respect to x. Let's write it as partial of f with respect to x. All right, so y is my constant, x is my variable. We get 12x squared minus 5y squared plus 3x squared y to the 4th plus 2e to the 2x. Make sure you've got that. The next time we are going to take the derivative of this output with respect to x. And so this is going to be the second partial of f with respect to x both times. Just double checking to make sure I've got this. It looks great. Okay, so I'm going to indent just a little bit. Second partial of f with respect to x squared. That's the notation. All right, so x again is your variable. So we're going to get 24x plus 6x y to the 4th plus 4e to the 2x. All right, I'm going to now find the partial derivative of f with respect to x and then y. This is my mixed partial, right? So the partial now of this line right here, but now x is going to be constant and y is my variable this time, okay? So y is my variable. X is constant, y is my variable. That's it. All right, let's check out the partial derivative of f with respect to y. All the way back to the beginning, to the initial function. This time y is the variable and x is the constant. Now I'm going to take the partial derivative of f with respect to y again, okay? So I'm going to springboard right off where I left off and take the derivative again. And x is still a constant because it's with respect to y. X is still a constant. All right, now I'm going to take the second partial derivative of f with respect to y and then with respect to x. So I'm going back up to this line and I'm using that. This time I'm taking the derivative with respect to x, which means I'm going to use y as my constant. Y is my constant. And that's what you should get. Notice that the mixed partials should be the same. Oops, I made a mistake, didn't I? Yes, y is my constant. Okay, now they're the same. Good idea to double check. The next example is going to involve the natural log. So nothing too complicated. I think we can handle this. First, take the derivative of f with respect to x. Okay, now I'm going to take the derivative of that output with respect to x again. So this is going to be f xx. Okay, so y is a constant. Next, take the derivative of x with respect to f with respect to x and then y. So I'm going back up to that answer. Actually, let's use this answer. And I'm taking the derivative of that answer with respect to y. So x is my constant. That's it. X is a constant. Okay. Take the derivative of f with respect to y. Okay, now I'm going to take the derivative of that result with respect to y again. This is going to be f, y, y. Second partial of f with respect to y both times. Okay, now take the derivative of this result with respect to x. That's your mixed partial now. So this is going to be f, y, then x. Okay, so y is my constant. And that's it. Make sure that your mixed partials are the same, and this time we got it.